here we have what is called the interface control concept. The bottom line from the interface control concept is, on a large system we get what is known as the interface control documents, or ICDs. Now, in order to get there, there's some things we have to do. We have to, in the systems engineering process, identify those physical, functional characteristics that are part of a system's development. And so what it's trying to say here is we have interfaces, like we have some common boundary. Okay, this is a little meatier right here. The types of interfaces: mechanical. Remember earlier I said mechanical arms, one mechanical component reaches another mechanical component. Electrical, I think we can see a little better. One electronic component now must interface with another electronic component. So we also have some other areas. Software is really obvious how it interfaces. Operationally is beyond the system, how a system functions within a larger group of systems. For example, how is our hypothetical aircraft going to operate with other aircraft that are flying? Is it going to interface with ground systems, communicate with them? Is it going to interface with satellites, perhaps? So those are the types of operational interfaces. And so, we go back and we look at the functional and physical architecture and determine where one component starts and ends, and to what degree we have to address those interfaces. And so it is a challenge to go through this process. Again, that's part of the systems engineering job, and the contractor will be doing that work effort, and we in the government are going to be managing it. Down at the bottom here, I have a little illustration just to kind of put this into perspective for you. When the new attack submarine went through the source selection process, the Navy had chosen Electric Boat as the winner of the competition. However, shortly thereafter, our representative here in Virginia at the time, the Honorable John Warner, said, "Wait a minute. From an industrial base perspective, if you give this contract to Electric Boat, then the other company that makes nuclear-powered submarines — obviously there are only two companies that make nuclear-powered submarines, one in Connecticut, one here in Virginia — if you give that contract to the one in Connecticut, the one here in Virginia will probably go out of business." So Warner had a good point. From an industrial base perspective, we don't want to have one company go out of business and then only have one company that can make these types of systems. That would be putting all your eggs in one basket. So Warner realized this, and Warner wasn't being parochial just because he's our representative from Virginia. He was also formerly the Secretary of the Navy. So he understood the concept of industrial base quite well. Once this information was surfaced, instead of the entire contract going to Electric Boat, they decided to make a partnering arrangement between both companies. So in the development today of the new attack submarine, you've got both Electric Boat making it and our company here in Virginia. Now, how exactly they make it, I'm not sure. I've been told that the front end of the boat is made by one company and the back end of the boat is made by another company. All right, that would make sense. So they're responsible for this part, the other company is responsible for this part. I do know this much. When you look at the film on submarine development, you realize that in a very compact space, this system of systems is a challenge. And the only way you can adequately attain what the customer wants is by modeling and simulation. And when you look at Electric Boat's capability to model and simulate these submarines, you realize from the film that they're broken down into modular sections that are fabricated, tested, and then once everything's working, are integrated, physically put inside the hull to fit. So this is very difficult work. And in order to make all that happen, it's right here. It's all about the design and then subsequently checking those interface control documents to make sure everything is working. There's a term called configuration management. Configuration management basically looks at form, fit, and function, like I mentioned to you a few minutes ago. But before I go into form, fit, and function, let me just cover some areas here. Here you have a definition of configuration management. It says to ensure that the description of the project or product is correct and complete. And that's true, all right. But what does it take to do that? Well, first of all, we start with what are called CIs. Critical items or configuration items. Different people call them different things. Either way, I don't care what you call it, as long as you call it a CI. A CI is significant. It means this is something we really have to spend the time and money on to make sure it's developed correctly. So what happens is, obviously, it's on our work breakdown structure. The CIs are chosen by the PM and noted, physically noted on the work breakdown structure. Once they're noted as a CI, then it's a matter of constant management. As an illustration here, software is automatically a CI. New technology is automatically a CI. Why? Because there are always problems with software in the development. And new technology is new, so we need to spend more time on it. So the PM chooses the CIs, they go on the work breakdown structure, and then they're intensively managed in time. Another concept here is called traceability. We want to make sure that as this thing is being developed, as our hypothetical aircraft is in time being developed, that whatever is put into that system, we have a way of going back and taking a look at it just in case changes are necessary years into the future. So these are normal configuration management principles. Now there's also this entity here called the CCB, Configuration Control Board. Their job is to take all those engineering change proposals and make sure they meet the common sense test. To make sure the customer needs them, to make sure it's appropriate, so forth. The CCB really is the responsibility of guess who? The PM. However, the PM's too busy communicating and managing the overall process, so the chair of the CCB is appointed by the PM, whoever the PM trusts, to take their place and make sure the technical effort of all form, fit, and function is accurate and correct. So here's an illustration of it. I got this illustration from a supervisor many years ago. He did his own maintenance on his car. And this is, I believe, a starter of whatever vehicle he had. So he realized he needed a new starter. And he went to the parts house and said, here's my make and model, I need a starter. And they handed him a box. Inside the box was a starter, and inside the box was this piece of paper right here. And basically what it's saying is that any one of these three starters will meet your requirement of form, fit, or function. In other words, it will fit in your engine, it will function like a starter, and the overall component will work as it's intended as a starter. That's what this is trying to say here. Well, I think originally he had this starter in his vehicle. In the box, he had this starter. So what he found was, you see this little thing back here? I think it's like a rod or something sticking up. That bit of deviation, that size right there, was enough for him not to be able to physically put the starter on his engine when the old one was taken off. He had to pull the entire engine out, put the starter on, and put the engine back in. That was the only way he could get it to fit in the engine. Once it fit on there, it worked. It met the other requirements. It worked as a starter. Okay. All I'm trying to say is, whatever company made this starter, they misrepresented themselves. It did not meet the fit requirement, as this illustration is trying to say.